Hi YouTube, this is Joe Calton with Calton Cutlery. You can find us on the web, caltoncutlery.com. This video is a continuation of my 440C testing to work up a base heat treat series of videos. The last video ended off with destructive testing on, I think it was 5 440C knives and the results of those tests. After I reviewed the video, which, by the way, I'm really enjoying doing these destructive tests on YouTube because, or at least on video, because then I can go back and actually watch the test. Like when I do a braking test, I never get to see what you guys see because I'm always behind, I'm always behind the knife doing the test. I don't get to see that same angle, and I can't stop it and replay to see exactly what angle it broke at. So doing these videos is an awful lot of fun, and I get to see what you guys get to see, which is really nice also. But anyway, so I took what I learned from the last series of testers and saw the videos and everything, and I did have really high hopes for the 440C, the 1/16 inch stock that had been in the kiln for 20 minutes before I quenched it in 140 degree or 145 degree canola oil. Just a single quench with a 300 degree temper for 2 hours twice. Going back through the video, I noticed that I said that the 15-minute one still had some chipping, whereas the 20-minute one did not. Based on that, plus I think the 15-minute one actually flexed a little bit farther before it broke. Based on that, I thought, okay, well, both of these were quenched at the same temperature, but one of them, and both of them were tempered at 300 degrees for 2 hours twice. But the 15-minute one, it was still a little bit harder than the 20-minute one, even after the temper. So that kind of told me that, okay, well, that 15-minute one, it came out of the quench a little bit harder. I don't have a Rockwell tester, so I can't test that part. So based on that and the brass rod test and the edge deformation test that I've got another video on, that pointed me in the direction of the 15-minute soak before quenching versus the 20-minute one. So what I did was I went ahead and I made 6 more testers. I did 2 of them at 15 minutes in the kiln at 1900 degrees Fahrenheit, 2 of them at 11 minutes in the kiln at 1900 degrees Fahrenheit. All 4 of those were quenched in 145 degree canola oil. And then Cliff Stamp suggested that I try a multiple quench on a couple of blades with a little bit of a twist. Like on my 1095 blades, I multiple quench those, but I heat them up and I quench them, and then I let them cool to room temperature, and then I heat them up again and quench them, let them cool to room temperature, and then I repeat that the 3rd time, and then they go in for their tempers. What he was suggesting was to heat it up, quench it, temper it, so that, and I'm no metallurgist here, but so that the retained austenite would be converted to tempered martensite, and then reheat it for the 2nd quench, and then temper as normal. The first one was I've got it written down here in my notes, but stuck it in a 2000 degree kiln for 15 minutes, quenched it in 145 degree canola, let it cool to room temperature, temper it. Now my toaster that I use for tempering won't go that high, so I stuck it back in the kiln after it cooled down, tempered it at 1000 degrees Fahrenheit for 2 hours, let it cool to room temperature, and then the next day heated it back up. I did one at 1900 degrees Fahrenheit and one at 1850 degrees Fahrenheit for 15 minutes, and then quench in 145 degree canola, and then temper both of them at 300 degrees Fahrenheit for 2 hours twice. Anyway, so here's all my notes, and you guys can use your pause button. I'll get the lanyard out of the way. Okay, so here was the heat treat on these 6 testers. Did it 7:31 of 15. 2 at 11 minutes at 1900 degrees and 145 degree canola. 2 for 15 minutes at 1900 degrees and 145 degree canola. And then the 2 that Cliff was interested in. Once they got out of heat treat, all 6 of them took 40 pounds at roughly a 40 degree angle and retained very small sets in the edge over the brass rod. Ground all 6 testers to 220 grit and sharpened with a coarse Smith's 12-inch 325 grit diamond honed. Now these cutting tests, move to the other side here. Now these cutting tests might need a little bit of explaining. These were the 6 knives. I only tested 4 of them for cut because I was doing 300 cuts per knife and then doing each one of them 3 times. So this was this table took 4,500 cuts in that manila rope to complete it. The best one was the 15-minute single quench. It measured 18 thousandths behind at the shoulder of the edge, and measured 33 thousandths a quarter inch back from the edge. You can see that a little bit better. The first cut took 6 pounds, or the first cut on the first test took 6 pounds to complete the cut. 8 pounds for the 100th cut, 8 pounds for the 200th cut, and then 9 pounds for the 300th cut. And then that's what those numbers mean on all of these. This part right here was where I wrote that down in the wrong spot, so it's supposed to be there. And then this one also. I also tested my personal Carter pattern necker out of 1095. Now, it also says here that both of the ones that were multiple quench warped slightly, whereas the other ones did not. My 1095 seems a little bit easier to sharpen and seemed to get a little bit slightly sharper. But you can see here, when you're reading these tables, you know, I'm only a man, I'm not a machine or anything, but you can tell. Now I did this set on one day and then this set the next day, which I've gone to doing that over the last 6 months or so because I think it takes some of me out of the equation. You know, if you're tired or in a hurry or, you know, thinking about something else, a lot of times you'll put a lot more force on the rope to cut it versus, you know, if you're in different condition. And then by spreading that out over 2 days, I think it gives you a little bit, well, I think it gives you better results. But anyways, you can see that the best one was the 15-minute single quenched, tempered at 315 degrees for 2 hours, and do that twice. Took 4 pounds for the first cut, 9 pounds for the 300th cut, for a 5-pound gain over 300 cuts in that rope. That's roughly the same as what my 1095 was doing. My 1095 blade only gained 4 pounds over 300 cuts. But, you know, I mean, I only did 3 runs with each knife. So if I did up to 6 runs, then that would, you know, tell a much better story. But anyways, so that's the cutting test. Now we're going to do the flex tests, or the bending and the breaking of the knife test. I think that light's a bit too much. Because now we have the steel to the point where it's pretty happy. It's cutting really well. It's doing really good in the edge deformation test. So, grab the safety glasses. And I'm not going to break my Carter pattern out of 1095 because I kind of like it. But we'll start off with this one, which was the multiple quench. First quench was from 2,000 degrees Fahrenheit, then a 1,000-degree temper for 2 hours, and then the next day heated back up to 1,850 degrees Fahrenheit for 15 minutes, quenched in 145 degree canola oil, and then tempered at 300 degrees Fahrenheit for 2 hours. Twice. Let me grab my gloves. The grain looks really good on that one. This one seemed to flex a little bit farther than the last set of testers, which I would kind of expect that because, well, no, this one wasn't tempered any hotter, never mind. Okay, now this one was quenched from a little bit higher temp on the second quench. This one's 1900 degrees instead of 1850. That one didn't make it quite as far. And once I get done with all these braking tests, I've been keeping the knives in little Ziploc baggies with the date on them, so that I have the details of the experiment, so then I can go back with my loupe or my microscope and take a look at them. This one was a single quenched at 11 minutes in the canola oil. The thought there was the same temperature but less time could make for a tougher blade. That one made it pretty far. Now this one right here was the best cutting blade, the 15-minute single quench, and this one is still full hard. I've got one more that I did. I used a propane torch to draw the tang in the spine to see if that would make any difference. But this one is straight, straight hardness throughout the whole blade. I think that one's the farthest yet. Now this last one, this one is one that I'm really excited about. Now like I said, I tempered the spine and the tang with a propane torch, and I was having a little bit of problems controlling the heat because a propane torch, the flame is really wide. So I got the tang tempered to a nice blue color, and then when I came in here to do the spine, I got a nice violet color on this side of the knife, just where I wanted it, but then on the other side of the knife it went farther down the edge. So I'll have to, depends on how this one does, I'll have to make up a couple of more of them and use an oxyacetylene torch with a finer tip so I can direct that heat exactly where I want it. Or I might be able to, I might have to use a water bath to keep the edge hard. So we'll see what this one does. It broke also, but it also broke right about where the end of the color change was. So we'll do that one again a little bit deeper and see if there was any differential tempering going on there. Boy, that, I thought for a second that one might make it to 90. But that does tell me that there was a difference in toughness there. I have to go back over the video, but I believe that one made it a little bit farther than the other one did. But basically, my base heat treat on these 440C knives are pretty much done. Now, when I say base heat treat, that's just the heat treat that I'm going to be starting with. There's a whole bunch more variables that I need to test. You know, what happens if I run the canola 10 degrees hotter or colder? What happens if now 15 degrees on the hardening temp, or the time on the at the hardening temp, so 1900 degrees for 15 minutes so far is the best. 11 minutes was a little bit too less. So what happens if I go 14 minutes at that temperature? Also, what happens if I drop my temperature 25 degrees? You know, a whole bunch of, you know, little fine tuning here and there is still needed, but the base heat treat is so far really good and surprising me quite a bit. So yeah, I'm pretty happy with it. I think I've got the actual tester that did the best in the cutting tests. This one right here. Again, this is Admiral's 440C stainless, 16th inch stock, straight as they shipped it to me, which they said is full annealed. Heat it to 1900 degrees Fahrenheit. Hold it for, or bring the kiln up to 1900 degrees Fahrenheit. Place the blade in the kiln. 15 minutes later, pull it out. Full quench into 145 degree canola oil. Let it cool to room temperature. Clean the blade off. Put it in the tempering toaster at 315 degrees Fahrenheit for 2 hours. Let it cool to room temperature. Put it back in the toaster. Do another 2 hours at 315 degrees Fahrenheit, and that's it. Like I said, an awful lot of little tweaks still need to happen. Plus, I haven't, you know, everybody says that stainless benefits quite a bit from cryo, so I need to get some liquid nitrogen and play around with that a little bit. But it's the base heat treat is done. I'm liking it quite a bit. Hope you enjoyed it, and see you next time.